Welcome to TestTrue, your go-to hub for professional knowledge sharing. In the previous tutorial, we discussed SOAP and REST are the two key types of web services. In this session, we will deep dive into REST, exploring its features and functionality. In this tutorial, we will cover Introduction to REST, the key concepts of REST, architectural constraints and principles, HTTP methods in REST, REST request and response structure, HTTP status code, REST authentication, and practical demo showing how to test the REST APIs. REST stands for Representational State Transfer. It is not a protocol, it is an architectural style. REST defines a set of principles, are also called as constraints, that a system or an application, basically the client and server, should follow to enable the communication between them. This communication often happens through the APIs over the internet. So basically, REST defines a set of principles or a constraints that the communicating system should follow. REST is based on the web protocol, primarily HTTP and HTTPS. Any web service that adheres to the principles or the constraints set by REST are called as an RESTful services. So, in case someone asks what is RESTful service, it is a web service that follows the principles or the guidelines or the constraints set by the REST are called as the RESTful services. So here if you see, REST stands for Representational State Transfer, where the client and server communicates over web using HTTP or HTTPS protocol. REST defines 6 core constraints or the principle that guides the design of the RESTful system. These constraints ensures that the system that are built using REST principles are scalable, maintainable, and efficient. The 6 constraints are client-server architecture, statelessness, cacheability, uniform interface, layered system, and code on demand, which is an optional constraint. We will discuss deeply each of these topics in a coming session. The client and server architecture focusing on separating the client functionalities from the server functionalities. Okay, the client is intended to perform certain operation and the server is intended to perform certain operation, and there should not be the overlap of the functionalities that the client and server performs. Since the client and servers are designed to perform the different functionalities, they can evolve independently and they can specialize in their roles. That is what client server architecture tells. It says that the client and the server are separate entities. They are the platform independent. They are the language independent that interact over a network. The separation allows each part to evolve independently and specialize in their roles. In most of the cases, client handles generally the user interface. It can be a mobile application or it can be a web application or it can be a desktop application. So client generally handles the front end part of it and server basically manages the back end process. Basically, it processes the data, logic, and the helps in building the logics and the services. Okay, what are the benefits that we get from the client server architecture? The separation allows the front end and the back end. The front end is the client and back end is the servers to be developed and scaled independently. That is that is why the client server architecture is very important. Let us consider an weather application in which the client can be a mobile application or a web application or any device that requests the weather data for a specific location. Here, the client sends an HTTP request through an API to the weather server asking for weather details based on the user location, that is longitude, latitude, and the city name. Okay, as part of the request it makes. The client is responsible once the client receives the response. Client is responsible for displaying this information on the user interface. The server side, on the other hand, which basically stores the weather data And this is an RESTful API service provided by weather providers like OpenWeather or an Weather API. When the server receives the client request, it it retrieves the necessary weather data either from the database or from the third party source. The processes this request and sends the response back to the client as an HTTP response, either in a JSON format or an XML format. So here if you see, the client and server operations are completely different. Client is responsible for sending a request with the current the city location in terms of latitude and longitude or a city name, whereas server basically uh, for a given latitude and longitude, it gets the data from the third party source, or it is already maybe stored this data into the database based on the data it receives from a satellite or somewhere. It stores the data into the database, or it uses another third party service to retrieve this data, and then basically it processes the data and puts in a format that the client expects and sends it back to the client. In this way, the server side functionalities are completely independent from the client side functionality. This is what the client server architecture defines. Statelessness. This means that server does not keep track of any of the client activities. So whatever the transaction that happens between client and the server does not keep a track of these activities. That means server does not store any of the history. This makes the client to send all the information that is needed by the server to process a request. So each request from the client to the server must contain all the information needed to understand and process the request. The server does not store any session related data between the request. What is the benefit that we get it from statelessness? Since the server need not have to keep a track of the complete history of the operation, this means this makes the server logic to be less complex. Okay, the benefit of the statelessness is scalability is enhanced because server does not need to keep track of the session states, allowing easier management of the client request. Let us explain statelessness with the help of an online shopping cart. Here the user is purchasing a product from an e-commerce website. He adds an item to the shopping cart and then checks out to complete the purchase. User perform this operation from the website, right? And the website in turn uses an API to add a product into the cart. It calls the this particular API add to cart API, which is an post call, and in the body he sends the product ID and the quantity. The server takes this receives this request, and it processes, it adds this product into the cart with the two quantities, and hit response back to the client telling that I have added this product, and this is the product ID, this is the name of the product, and this is the price you need to add. Now let us consider the user changes his mind and he wanted to add one more item of the same type. Now what he does, he goes to the website and adds one more wireless headphone. Now client calls add to cart API to add the newly added product. Since the server does not store any history of the transaction, server does not know that there are already two products that are added to the cart. Now it's client responsibility to send the the product quantity as 3 to tell the server that I want to add the wireless headphone, which is of the product ID this one, with the quantity 3. In the stateless architecture, the server does not keep a track of any session data. Every request from the client must contain all the necessary information for the server to process it. That is why in the particular request, when the user adds a new item, instead of 2, the client has to send the quantity as 3. Here the client is the one who keep tracks the number of items that are available in the cart at a given point in time. Whenever the new item is added, it will send the total number of items that should be made available in the cart. Third constraint is called as cacheability, which is an ability of the client to store or cache the responses from the server for future use or to reuse. This is all based on the instruction from the server. In the response header, there is a field called cacheable control. If this cacheable control is set, then it tells the client to cache the response and reuse for the future purpose. Okay, the responses from the server must be explicitly marked as cacheable or non-cacheable. If the response is cacheable, then the client stores it for the future request, reducing the load on the server. So what is the benefit that we get from the cacheability feature? It reduces the server load because server need not have to process the client request again and again, rather than the client can reuse the response from the server, and it improves the performance by allowing the client or an intermediate servers to reuse the previous responses whenever it is appropriate. Let us consider an example of weather API. Here the user is residing in a New York City, and whenever he opens an weather application, the weather application sends a request to the server to get the current weather data for the city New York. Since the weather data does not change every second, here the server sends the response back to the client telling to cache this particular request for the future use. Every time user opens the application makes a get call to the server with passing a query parameter as a city equal to New York. The server responds to this particular request, sending the current weather condition including the temperature, humidity, and the wind blowing direction, the wind speed, etc., etc. Along with that, it also sends an header with the metadata cache control public max age equal to 600. This basically tells the client that the response to be cached for 10 minutes. Okay, this basically tells that response to be cached for 600 seconds, that is equal to 10 minutes. If the user reopens the app and refreshes the page within 10 minutes, the client uses the cached version of the response. It is not going to make any call to the server. It uses the cached response. If the user reopens the app or refreshes the app after 10 minutes, then the new get call is made towards the server trying to get the latest weather data. This is how the cache control or an cacheability feature works. Constraint number 4 is uniform interface. Before we discuss more about uniform interface, we need to understand certain terminologies. In a RESTful service, each and every piece of information is called as a resource. Resources are any piece of information or an object that a server can provide or manipulate. It could be an user profile, or it could be an product in a store, or it could be an image or a collection of objects. Consider an example where the government is maintaining the user identification web service. This web service stores the important information such as the name, ID, the phone number, address, and biometric data. Okay, so if you see this JSON structure, this is how the user details are basically stored in the server, which will be stored under a collection called users, under which each element is the user details. In this structure, each user is treated as a resource, and the individual details like name, address, biometric data, the email, these are considered as an attributes of this particular user. Second important terminology is URI, Uniform Resource Identifier. It's a unique string that helps to identify a resource on a server. If you want to identify the user by an ID 12345, you can use an URI users/12345 prefixed by the base URL of this particular web server. The third terminology is called as representation. Representation is a data format that describes the current state or a detail of a resource. When a client requests the resource, it receives this representation from the server, which could be in a format like JSON, XML, or an HTML. If you want to get a detail of this particular user by making a request get the base URL slash user slash 12345, then the server gives the current representation of that particular resource, which is something like this: ID equal to this one, name equal to this one, email, and etc, etc. These are the three important terminologies that are used, and it will be required to understand the fourth constraint, the uniform interface. Uniform interface, which is the fourth constraint, that says that REST relies on a uniform interface between the client and server. The client and server both should follow an uniform interface. This constraint includes the following principles. First one is an identification of resource, which is called as an URI. Every resources are identified uniquely using URIs. The manipulation of the resources through its representation. So client interacts with the resources by using the representation, that is the current state of that resource, typically in a formats like JSON, XML, or HTML. Self-descriptive messages, that means each message contains enough information to describe how to process the request, right? So that is also we told in the statelessness, right? So 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 server does not maintain the state of the transaction, therefore it's responsibility of the client to send a request which is descriptive and has all the data to process that request, which includes the body, the headers, the metadata, whatever is needed, etc, and etc. What is the benefit that we get out of the uniform interface? It simplifies the architecture and makes the API more standardized and easy to understand. By establishing the uniform interface, we can standardize the communication between the client and the server. The layered architecture or a layered system, which is the fifth constraint, that says that between the client and server there can be multiple layers or a multiple systems which has a dedicated functionality and able to process the request and pass the request from one layer to another layer till the server. The REST architecture can be composed of multiple layers, with each layer is responsible for specific aspects of the system. Each layer is responsible for particular piece of the functionality. Example: the firewall responsible for security, the load balancing, the API gateways, the data storage, and etc, etc. The important thing is client is unaware of the complexity and also the presence of these intermediate layers like gateways or caches between itself and a server. What is the benefit that you get from the layered system? This layering improves the scalability and the flexibility, allowing the architecture to evolve and maintain over a time without affecting clients. So you can basically share the complexities, right? So when a client sends a request, if it is not a layered system, it directly goes to the server, and server needs to do lot of aspects. It needs to check the security aspects. It needs to take care of lot of aspects. But in order to take the burdens, these kind of burdens from the server, so there are this particular constraint says that you can have a multiple layers which are responsible for performing a certain functionalities. This allows the system to scale up very easily. Let us understand the layer system better with an example. Let us consider an example where your organization has developed a microservice. Microservices is nothing but an API which is hosted on a multiple servers to improve the availability. That will be consumed by a third party application. Here third party has third party company has developed an application which uses the microservices from your organization. In this particular example, we have the three different networks. One is the client network where the application client application is hosted. Another one is called as an DMZ, which is a demilitarized zone, which basically a zone that allows an external network to communicate with your internal network. This is basically your internal network where you have hosted your microservices or your APIs. Okay, this is a kind of an layered architecture, right, where you have a client and a server. In between the client and server we have a load balancer and we have an API gateway. Okay, this basically tells about the layered system. Okay, each system is responsible to perform certain activities. Okay, here the client user interacts with the front end interface, right? This is where user interacts with the front end interface. The load balancer basically routes the request across the several uh, several servers. Basically it is responsible for distributing the load in order to prevent the overloading of a particular server. API gateway is a central entry point for all the client requests, distributing them to the appropriate service. Once the load balancer distributes the load into a API gateway server, API gateway server in terms points to the particular service within the bunch of servers, which basically points to a particular service in the set of servers, right? Then you have an application service, which is where basically your the web services are hosted. So in between the client and the your web service there are multiple layers. Here we have load balancer and API gateway. Each one is responsible to perform its own operation, which takes the burden from the server in performing the complex kind of an operation. So this helps the entire service to scale actually. That is why we use layered system. The sixth and final constraint is code on demand, which is optional. This constraint is an optional and allows the server to deliver an executable code. Here, along with the response, server sends some executable code, which is some kind of an Java code or a JavaScript to the client on a demand. This code can extend the client functionalities temporarily. While not widely used in REST, this can be beneficial in certain situations where the client functionality needs to be enhanced dynamically. Okay, benefit adds and flexibility by enabling the server to deliver the dynamic functionality to the client without needing to the client side updates. So here basically what happens is on demand the server sends some kind of a JavaScript which can be executed by the client. This is code on demand and it is an optional constraint. These are the 6 constraints or the principles that the web service to adhere to to become a RESTful web service. Hope you understood this concept. REST supports below methods: get, post, put, patch, delete, head, and options. Get is used to retrieve the information. Post is used for creating a new resource on a server. Put is used for updating an existing resource or creating a new one if it does not exist. The patch is to partially update an existing resource. Delete is to delete a resource from a server. Head, basically it is equivalent to get, but it only retrieves the header information. Options method gets a list of operations that we can perform for a given API. Okay, I will also explain this with an example at the end of this session during the practical session. The HTTP request has 4 parameter address, which basically the unique identifier to identify the resource. The method, the what kind of operation that we are going to perform. It may be a get, post, put, etc. The header contains the metadata, whereas the body is an actual data that we pass to the or send to the server. The first one is address, which is also called as an URL or URI. The full form is Uniform Resource Locator or an identifier, which basically an address of the resource that you are requesting it, which is a combination of a server address and a path to a particular resource. In this API, basically we are using api.weatherapi.com, which is the address of the server, and current.json is a resource that we are requesting here, right? So which is called as a resource here, which is a resource, here. Second one is about the method. The method basically tells what kind of operation that we are performing with the particular resource. In this case, we are performing a post request. That means we are trying to create a new record, or you are trying to update the existing record on a server. The commonly used methods are the get, which is to retrieve the data from a server. The post is to create a new record or to modify the existing record on a server. Put is basically to update the content of the existing record on a server. Delete is to basically delete already existing record from the server. Headers are some metadata or some special information that is needed by the server in order to understand the request and to process the request. If you see in this case, we are passing a header as a content type, which is of JSON format, that we are telling the server that the message body from the request is of type JSON, and please use the JSON parsing method to parse this data. Sometimes the communication between the client and server are protected. In such cases, you need to send some keys in order to perform the authorization, which can be a basic username or a password, which can be a personal access token, or it can be an OAuth token that is used for the communication that allows the client to communicate with the server. These are basically headers are basically some special information or a metadata. The body is an actual information that is sent to the server. It's actual data that is being sent to the server. Typically, the body is used in request methods or like post, put, or a patch. In case of a get, we generally don't use the body, which has been empty. In this example, what we are sending to the server is about the geolocation. We are trying to post a request with the geographical location. For example, if you see, we are sending the coordinate in terms of latitude and longitude, or the location as a London and things like that, to get the data from this particular weather data from these particular locations. Okay, and the body the content of this body can be of format like JSON or an XML. If it is a JSON, then we will specify like application/JSON. If it is an XML, we specify application/XML. After processing the request, the server sends a response back to the client, and the structure of the response is something like this, which has got a status code followed by the status description, header, and a body. Status code is a 3-digit code that indicates the outcome of the request. Some of the common codes are 200 OK, where the request is successful. 404 is an resource not found. That means you are trying to access some request which is not available in the server. 500 is something wrong in a server. This is an internal error server. So I will take you through some comprehensive list of status code at the end of this video. The header, like how we have a request header, we also have an response headers, which are basically a metadata. Which also, if you see, some of the commonly used metadata are the content type or the content length. Here basically it tells the response, the body that server sends back to the client is of type either JSON or an XML. It also says how many bytes this body contains, right? response body contains. Okay, and that is not documented here. This is here it is only shows a body. The body is basically the content of a response, which can be in the form of HTML or a JSON or an image or etc etc. Sometimes you can also have an empty body. For example, you are trying to create a new record using a post, then you will get a response code as 201 that says that your request has been created, but there is no body that has been sent, right? So these are all the sometimes there can also be a body content which can be an empty, all right? So for the last request that we sent in the last slide, we have seen the structure of the request, where we have sent a request to the server, post request. In response to this post request, the server has sent this particular data, which is in a JSON format, which basically contains a lot of information like the location for which the weather data is being sent, what is the coordinate, what is the region, and basically if you see, it completely tells about the weather data, like what is the temperature in centigrade, in a Fahrenheit, uh, for how long this data is valid. Is it for a week or is it for a day? And the wind speeds and etc etc. This is how basically the response structure looks like. Supported authentication, I have listed only few of them. There are more authentications types that is supported by the REST. The basic in the basic one, um, while sending a request, client sends username and password. This username and password is sent as the base64 format to the server as part of the header with the key called authorization. The bearer token, here the token based authentication, where the client sends a token in the header with the key as authorization, the followed by the bearer, then space, then a token. The example could be something like this: authorization colon bearer with the token. OAuth2 is another token based authentication in which the client first sends the client ID and client secret to an authorization server. The authorization server basically checks the authenticity of this particular client. When it passes, it sends the token back to the client, and client uses this token to communicate with the server. The API key, it is another type of the authentication, a unique identifier provided to the clients to authenticate the request. The key is usually sent as an query parameter in the request. These are some of the authentications that are supported with the REST. Let us do a little bit of hands-on testing the different HTTP methods using a REST API. Yeah, for this activity, I will be using request response.in website. Okay, this particular service is exposing the lot of APIs to perform the user management. Let us use them in a Postman. In case if you don't know how to use a Postman, please watch my video where I explain complete testing of APIs using Postman. Let us try this particular API, get single user. Here we will be using this particular request. Let us go to Postman and try to create a request, and we should also have a base URL, right? And let us try this. If you want, we can save this. We'll create a new collection for this, like the name testing the test HTTP methods. Sorry, sorry, I did a mistake. Save. So this went back this here. So I have to create a new collection, test http methods, then create this collection. Under this collection I can give get user 2, user with the 2, right? Just save this and let us run this request. It says 404. Yes, maybe this could be an issue, extra path here. Let us save this and try to execute again. Yeah, now it is successful. So we got the detail of this particular user. This is how get works. Now let us use a post method. Post method is used to create a new record, right? New resource within the server. Okay. Again, we will be using this particular path and create a new request and make it as a type post. Then take this as a base URL. Go to Postman. Yeah. So avoid this double thing. Save it. We can create as a create user. Save this. Then for post request basically needs a body, right? We can give a body and the structure of the body is like this. Okay, let us come back here, click as a row, give as a structure, put it as test troop, here give it as a trainer, save this, send this request. See, it says that it has created a new resource with the name test troop and the ID is 460. So this is how the post request works. Now let us try the other request, which is called as put, which is basically to update a existing record. Let us try a put method. We will try to update the user with an ID 2. Okay, this is basically we are trying to update an user with an ID as 2. Let us take this. Let us go to the Postman and try to create a new request which is of type put. The value is this. Yeah, we can select this, but here we have to put a body. It says that we have to send a body. We'll send the body something like this. It is of type raw. Will be, so if I see here get user, the user ID is 2, email is this one, first name is Janet and Weaver, the name is Janet and Weaver, but we are going to change that basically here, and we are trying to give as http put job is testing. Let us send this request, let us save this request as update the user, save this and try this. So it is successful. Okay, it has changed the, it has basically changed the user with an ID 2. Let us try patch, which is going to update the record partially. So in the put example, in the body we were passing both the name and job, but we will in case if you want to change this particular user record, only the job. Okay, if you want to change his job description from testing to development, then you can use the patch method instead of the put method. We'll take the same example. We will come here, instead of put we'll make it as a patch and we will take the same content body, and in the body, in the raw, we can go and you can just remove this one, the first element. So we're keeping the name as it is, but we are changing the job description. Let us save this as patch or partial update. Partial update. Let us save this and let us execute this. See, it gave us a response telling that the job description has changed. This is how the patch method works. Now let us try to delete a particular resource. Let us try attempt to delete the resource, the user with an ID 2. This is a particular resource I want to delete it. For that I will be using the same endpoint, because I am trying to delete the user with ID 2, and I am using the method delete method. So if it is successful, then I will save this. I'll give it as a name delete, and I'll save this and I will send this request. If it is successful, it says no content found. Let me try to go to this website to check whether it is correct or not. A delete method, yeah, it says the response is 204. Okay, that is correct. That is what is expected. Um, According to this particular website, it says that 204 is expected. We are also getting the same response here. So that means it is correct. So we have also used another method which is called as a head method. Head method, I told, it is the get method, but it will be getting me only the header. It will not get me the body, right? So if I go to the console, here, which is mainly used for debugging purpose, I'll clear the console and try to execute this. And if I expand this, then you can see the response in the under the, let us close this request. Under response, you see the response header and the response body. Okay, so when I execute a get, we will be getting the complete content, including the status code, the description of a status code like 200 is okay. Then along with that, I am getting the response headers and the response body. But if I use the head method, let us see what it gives. Try to use the head method, and let us save this, give it as header information only. Save this and we'll clear this console and we'll try to execute this. Execute it properly, successfully. When I come here, you see I have the response header, but the response body is empty. But in case of get, let's clear this, try to execute this. I have a response body as well, right? This is the difference between the head and the get. The head gets only the header information from the response get, but get, in case of get, we get the response headers as well as the response body. Let us try the final method, which is called as options. Let us go to options and try this, and let us execute this. Okay, first let us clear this. Let us execute this. Executed option, and if you see in the response header, you can see the access control allowed methods. It says the get, head, put, patch, post. These are the allowed methods for this particular API. This is how options works. Hope you understood that how to use the different methods, HTTP methods, for a REST API using the Postman. That brings to the end of this session. Hope you enjoyed learning with me. In this tutorial, we learned what is REST, the architectural constraints defined by REST, what are RESTful services, HTTP methods used in REST, REST request and response structure, the HTTP status codes, some of the REST authentication, and the practical demo showcasing how to test the different methods of REST. In case if you find this video useful, please support me by subscribing to my channel. Thank you.